The embankment subsoil subjected to multidirectional seismic loading simultaneously, prediction of strain stress mechanism. It's my research work and I would like to present no abstract. In this study, I used AWAGES to analysis of strain and stress developed due to the near-fault ground motion applied on the embankment subsoil model in single and multi-directional, and to control quality of the numerical simulation, the statistical analysis applied to the result, which was selected from the several stages of the numerical simulation, and to prediction strain and stress and density mechanism of the stress and strain. The statistical model were developed. According to the statistical analysis, result confirm the multidirectional seismic loading when applied to the embankment subsoil model has result with better quality. An outcome of this study enhanced the quality of numerical simulation and prediction of the embankment subsoil model seismic response, and it can apply on several engineering problems. Introduction. The limitation of research in using numerical simulation is related to simulate boundary condition and application of seismic load on multidirectional to the model when we use the FEM software. The numerical simulation need a suitable boundary condition, a boundary condition which present realistic situation when the seismic loading is applied on the model. In most of the case, just the applied seismic loading in horizontal direction. It needs to apply seismic loading on 3-directional for prediction of the stress strain mechanism. The main objective of this study is to analyze model seismic response on single and multi-directional seismic applied loading, and the accuracy of the work need to be verified using statistical modeling. The method I use is a simple FEM software seismic simulation based on seismic loading is recorded by a station, and developing a model based on the mechanical property of the material is reported in the literature, and analyzing of a strain and a stress, and the finally assessment based on the statistical analysis. Analysis procedure is FEM software, numerical simulation using AWAGES, mechanical property of the material, and result verification. This is a simple and briefly of this research work. The embankment subsoil model is presented. The geometry of the embankment subsoil model is presented in this picture. The seismic load based on the acceleration is in the three-directional X, Y, and Z direction. Each direction has different behavior. If you use just X direction, the result it will not be same. And in the modeling, hexahedral mesh of 4000 millimeter size selected for the modeling, and the boundary condition. First, at the first, the seismic loading is applied in X direction in the boundary condition is shown, and in second part, the seismic loading is applied in X, Y, and Z direction. It's a two different boundary condition. What's the new part is the second part of the boundary condition. Flowchart for simulation. The flowchart for simulation is briefly present of the research methodology used in this work, starting by modeling, then applying seismic loading analysis using the software, assessment and validate. At the end is the process. Then explanation about the seismic loading. The earthquake with magnitude of 6.2 was recorded, and based on the ammetries station, this earthquake data was used in the numerical simulation. And in statistical modeling is based on the linear regression model for assessment of the stress and strain. Result. After finishing analysis, the strain in middle strain and stress in middle stage of the numerical simulation. We have several stages of the numerical simulation. I selected in the middle stage. In the middle stage is here what I have in X direction is different from the Y direction. Result. What result is here? The stress and strain behavior of model associated to nature of seismic loading. Seismic loading if is in X direction or in Y direction. When is in X direction or single X direction or is X, Y, and Z direction. When the load is applied in multidirectional, then what is developed? Load interaction, seismic loading interaction is effect to the stress and strain. There are two different vibration mechanisms when seismic loading is applied in X direction or seismic loading is applied in X, Y, and Z direction. In apply multidirectional seismic loading on the model, lower vibration occur. The statistical model show higher accuracy occur to simulation with apply multidirectional seismic loading on The result of the linear regression analysis, strain stress in all stages of the numerical simulation. When seismic load is applied in x direction, it can be found the differential displacement is too high. Vibration is more nonlinear, and it expects higher damage. And of course, is effect to the accuracy of the result. The statistical analysis. The result of a statistical analysis shown R square and RMSE, x direction and x, y, and z direction. In both cases, can find acceptable quality, but higher quality appear when applied seismic loading in x and y and z direction. Conclusion. The seismic loading in single and multi-directional was applied on the embankment-subsoil model. The new method to develop boundary condition present for the numerical simulation to solve geotechnical earthquake engineering. It can be applied in several branches of the science and technology. Result verified using statistical modeling. According to statistical analysis, the result relieved the applied multidirectional seismic loading to the embankment subsoil model has better result quality. The outcome of this study applicable for prediction of the strain, energy density, and magnitude, and forecasting strain stress behavior of model. The reference, and thank you so much for attention. If you have any question, you can contact me on this email.